Our next lesson is about sine and cosine of complementary angles. In our last lesson, we talked about that there's some kind of relationship between sine and cosine, and we'll talk about that relationship in this video. There are two CCRSM standards. The first is to explain and use the relationship between the sine and the cosine of complementary angles, and then SRT8, which we've seen before, where we're using trigonometric ratios and the Pythagorean theorem to solve right triangles in applied problems. Let's get started. Let's start the video at the very beginning of lesson 26. In this lesson, we are defining sine, cosine, and tangent, which we've already done in the previous video, but now we're looking at it through the lens of how is sine and cosine related. In number one, we've been asked to identify the opposite over hypotenuse ratios for angle A and angle B. We've already defined the opposite over hypotenuse as the sine ratio. So let's look at the sine ratio for angle A and then the sine ratio for angle B. So here's angle A, and the sine of A is the opposite over hypotenuse, so the leg opposite of A is 12, and the hypotenuse of the triangle is 13. Now, for the sine ratio of B, B's over here, and the sine of angle B is, again, the opposite of B, which is 5, over the hypotenuse, which is 13. In number two, we've been asked to identify the adjacent over hypotenuse, which is the cosine ratio. Now, the cosine of angle A is the adjacent, which is the adjacent leg, which is 5, over the hypotenuse, which is 13. And the cosine of angle B is the adjacent to B over the hypotenuse, 13. And the point of today's lesson is noticing that the sine of A is the same as the cosine of B. And the sine of B is the same as the cosine of A. So you should see those are the exact same ratios. And we'll talk a little bit later in this video about why that's the case. But for right now, notice that the sine of A is the same as the cosine of B, and the sine of B is the same as the cosine of A. Lesson 27 is about the sine and cosine of complementary angles and special angles, but we'll do this part in our next video. We're going to focus this video only on the sine and cosine of complementary angles. In example 1, we're asked to, we'll show that the sine of alpha is equal to sine of beta. Now, one thing that's done more and more as you get higher and higher in math is that Greek letters like alpha and beta are used for angles. I'm not sure why this is, but capital letters are always used for points, and lowercase letters are used for variables and side lengths, and Greek letters are used for angles. And that helps with when there's diagrams that we can clearly look at this picture right here and say, well, I know that capital A, capital B, capital C are points, lowercase a, b, and c are lengths, and that the Greek letters are angles. So as there's lots of complicated diagrams in the future, you'll be able to identify what is what in the diagram. Anyway, so the sine of alpha, this angle, let's see here. So our mnemonic is so ka toa. Make sure you can spell that because otherwise it's not very useful to you. And the sine is the opposite leg, which is A, over the hypotenuse, which is C. The sine of beta is again the opposite, which is B, over the hypotenuse, which is C. And the cosine of alpha is the adjacent over the hypotenuse, B over C. And the cosine of beta is the adjacent, which is A, and the hypotenuse, which is C. So again, we'll notice that the sine of A is the same as the cosine of B, and the sine of beta is the same as the cosine of alpha. Okay, now this was not done using numbers like the previous examples, but this is done with variables, and so we can generalize this for any right triangle that the sine of alpha is the same as the cosine of beta, and the sine of beta is the same as the cosine of alpha. In our next exercise, we're looking at what is alpha plus beta. So in this right triangle, we know this is 90 degrees. We also know that the three angles will add together to be 180 degrees. So I know that alpha plus beta plus 90 must equal 180 degrees. And if I subtract 90 from both sides, then I find that alpha plus beta equals 90. Now, back much earlier in this year, we talked about complementary angles and what complementary angles are. And complementary angles are two angles that add together to be 90 degrees, which means that alpha and beta are complementary angles. I want to point out one more fact before I move on to B. Based on the fact that alpha plus beta equals 90 degrees and based on the fact that they're complementary angles, we can say that alpha is equal to 90 minus beta, and I can say that beta is equal to 90 minus alpha. And that will show up from time to time with this idea that they're complementary angles, and one is the sine, the sine of one is the cosine of the other in those facts as well. So keep a lookout for those because that'll show up in a little bit later in this video. Okay, so B, use trigonometric ratios to describe BC over AB two different ways. So BC is here, and AB is the hypotenuse. So I can say that BC over AB, this is, if I'm looking at alpha, then that is the opposite over the hypotenuse. That is the sine of alpha. It is also, if you're looking at beta, BC is the adjacent to beta, and so it's the adjacent over hypotenuse, which is the cosine of beta. Now, the problem doesn't ask for this, but I want to go one step further and to use this idea with 90 minus beta is the same as alpha. I could also write this as the sine of alpha, and alpha is 90 minus beta, that I know that BC over AB is also equal to the sine of 90 minus beta, because alpha equals 90 minus beta. Similarly, I can substitute 90 minus alpha in for beta and say that BC over AB is equal to the cosine of 90 minus alpha. Okay, whenever you see 90 minus alpha, you're looking at the complementary, the other angle for that one. Next in C, we're looking at AC, which is this length down here, divided by AB, the hypotenuse. And again, if we're looking at at alpha, then AC is the adjacent divided by the hypotenuse, which adjacent over hypotenuse is the cosine of alpha. And if you're looking at beta, then AC is the opposite of beta over the hypotenuse, which is the sine of beta. But using the idea we discussed earlier with that alpha is equal to 90 minus beta, I can also write that this is equal to the cosine of 90 minus beta, and I can write that this is the sine of 90 minus alpha, because beta is equal to 90 minus alpha. Okay, in D, what can you conclude about the sine of alpha and the cosine of beta? Well, they're equivalent, they're equal. And E, what can you conclude about cosine of alpha and the sine of beta? They're equal. In number 2, we're asked to find the values for this symbol, which if you've not seen it before, this is theta, the Greek letter theta, that makes each statement true. The sine of theta is equal to the cosine of 25. Well, we've talked so far that the sine of one angle is the cosine of the complement, which means theta plus 25 would have to equal to 90. And I can subtract 25 from both sides, and theta must equal 65 degrees. Similarly for B, the sine of 80 degrees is equal to cosine of theta. Again, the complement, the sine of 1 is equal to the complement of the cosine of its complement. And so 80 is equal to, well, 80 plus theta is equal to 90 degrees. I can subtract 80 from both sides and get theta is equal to 10 degrees. Okay? C, again, we're noticing that these angles are complements. Theta plus 10 equals 90. And just by doing some algebra, I can subtract 10 from both sides. And theta plus theta is 2 theta is equal to 80. And I divide by 2, and I find that theta is equal to 40. Okay, now that's enough for me that you get the sense of how to do these problems, how to look at the fact that the sine of one angle is equal to the cosine of its complement. This video is about the sine and cosine of complementary angles, and I'm hoping now you're able to explain and use the relationship between the sine and the cosine of complementary angles. Thank you for watching.